Welcome students. So this is the integral that we've been given, integral dx over secant x positive secant 2x. Now this looks a straightforward integration, but it has got some process that we need to be applying to. Now foremost, what I'm going to do is I'm going to say let t be equal to tan of x over 2. Now I'm going to be differentiating this with respect to x. So when I do that, on the left, differential of t is going to give me dt. On the right, differential of tan of x over 2 is going to give me secant squared x over 2 times differentiation of x over 2. That's going to be 1 over 2. That into differentiation of x is going to be dx. So this is what we have got. Now I'm going to rewrite this as 2 times dt is equal to secant squared x over 2 of dx, and then I'm going to push this secant squared x over 2 to the left, and that would give me dt over secant squared x over 2. On the right side it's going to be dx. Now t is tan of x over 2, so I'm going to rewrite this as, I'm going to start with dx. dx is equal to 2 times dt over, now there is a trigonometric formula which we all have studied, so that is nothing but secant squared x negative tan squared x is equal to 1. From here I can rewrite this as secant squared x is equal to 1 positive tan squared x. So I'm going to use the same formula. Now if I were to use this formula, this is going to give me, instead of secant squared x over 2, I'm going to rewrite that as 1 positive tan squared x over 2, which is equal to, now tan x over 2 is t, so this is going to be 2 times dt over 1 positive t squared. On the left I've got dx, so my dx is this. Now having obtained this, we will have to also obtain the representation for cos x. So I'm going to start off like this, 1 negative tan squared x over secant squared x. Now what is this exactly equal to? Now this is going to be equal to, if I were to rewrite tan in terms of sine and cos, this is going to give me sine squared x divided by cos squared x, and secant squared x is nothing but 1 over cos squared x. So let me just have secant squared x for the time being as it is. Now this is equal to, I take the LCM as cos squared x, so that's going to give me cos squared x negative sine squared x divided by 1 over cos squared x, and I've got a denominator of secant squared x, so that secant squared x have to be placed. Now cos squared x minus sine squared x, what is that? That is nothing but cos 2x. Now clearly cos squared x and secant squared x, they get cancelled, so I'm left with this. So now I have got a representation. So what is the representation? If I were to, instead of saying equal to, I'm going to use the word consider. So consider 1 negative tan squared x over secant squared x. So now I have reduced this to this, so I want to rewrite this again. So this would mean I got a new representation, which is cos 2x is now equal to 1 negative tan squared x over secant squared x. Now this is the case for cos 2x, but I don't want cos 2x, I want cos x. To avoid confusion, what I'm going to do is I'm going to rewrite this in the place of 2x. I want to rewrite this as 2 theta. I don't want to have this symbol because it might be more confusing. So this is nothing but, I can rewrite this as cos 2 theta is equal to 1 negative tan squared theta divided by secant squared theta. Now this is the formula which we have obtained. Now I want to actually get cos x, so let 2 theta be equal to x. So from here theta is equal to x over 2, right? So by this substitution, what happens, this is going to be cos x and this is going to be 1 negative. In place of theta I'm going to substitute x over 2. So this is going to be tan squared x over 2 divided by secant squared x over 2. So this is what I've got. Now this is equal to, now we have assumed the value of t to be as tan of x over 2. In other words, tan of x over 2 is equal to t. So I'm going to substitute that. So this is equal to 1 negative t squared divided by, now secant squared x over 2. Now we actually replaced secant squared x over 2 as 1 positive tan squared x over 2, which is nothing but 1 positive t squared. So this is going to be 1 positive t squared. Now all this we did to get the expansion for cos x. So this is for cos x. So let me just write that down. So from here, therefore I've got cos x to be equal to 1 negative t squared divided by 1 positive t squared. So this is what I've got. So probably I can box this result. Now I've got cos. Now what I need to do now is I need to obtain secant 2x, and also I need to get secant x. Now that is another thing. So let us go and get secant x. Now you have to know that secant 2 theta, I can rewrite secant 2 theta. There is a trigonometric representation like this, that secant 2 theta is nothing but 1 positive tan squared theta divided by 1 negative tan squared theta. Now I can show that to you now. Now this is the formula. Now consider this, 1 positive tan squared theta. Now if I were to change this into sine and cos, this is going to give me 1 positive sine squared theta divided by cos squared theta divided by 1 negative tan is sine over cos. So this is going to be sine squared theta divided by cos squared theta. Now this is equal to, I take the LCM as cos squared theta. So this is going to give me cos squared theta positive sine squared theta divided by cos squared theta, and this is divided by, I've got the LCM as cos squared theta here also. So this is going to be cos squared theta negative sine squared theta divided by cos squared theta. Now cos squared theta can be cancelled. Cos squared theta plus sine squared theta is 1. I got a cos squared theta negative sine squared theta, and that is going to be cos 2 theta, right? So my secant 2 theta is as a representation in this fashion. So but what is 1 over cos 2 theta? It is nothing but secant 2 theta. So I did all this just to show you that this representation is valid. Now so what I want to do is I want to get secant x from here. Now just to avoid any confusion, I will just have this x as theta here. Now just to show you that substitution. So this is actually theta here. Now probably we can just directly come from here. Secant 2 theta is written in this fashion just using this formula. So we don't need this substitution. So now what I want to do is I'm going to take, let 2 theta be equal to x, because I want to find secant x. Now from here I get theta to be equal to x over 2. Now because of this substitution, what happens, this is going to be rewritten as secant 2 theta is x. So this is going to be secant x followed by 1 positive tan squared, my theta is x over 2. So let us place that x over 2 there. So this is going to be x over 2 divided by 1 negative tan squared x over 2, which is equal to, we started our substitution with t being equal to tan of x over 2. So I'm just going to substitute there. So 1 positive, that's going to be t, because tan squared, so I have to place the 2 there, followed by 1 negative t squared. So this is the representation. So let me write that down. So secant x, so therefore secant x is now rewritten as 1 positive t squared divided by 1 negative t squared. So let me box that. Now we got cos x, we got secant x, so now we need to find secant 2x. As I mentioned to you, there isn't anything we can do using this representation for secant 2 theta. So what I'm going to do is I'm going to start off by using the representation for cos. So we know that cos 2 theta, now cos 2 theta is equal to 2 times cos square theta negative 1. So we know this representation. Now this is fine, I don't have to have any substitution for this case because I can directly use the representation for cos, which is already obtained here. So this means I can rewrite this as cos 2x is equal to 2 times cos squared x negative 1, which is equal to, I'm going to substitute the representation for cos x, which I've got 1 negative t squared divided by 1 positive t squared. So this is going to be 2 of 1 negative t squared divided by 1 positive t squared raised to the power 2 negative 1. This is the representation that we have got for cos. Now you will understand why am I finding the value for cos 2x within a minute. Now what I'm going to do, I'm going to simplify this. This is equal to 2 times of 1 negative t squared raised to the power 2 divided by the denominator, which is 1 positive t squared raised to the power 2 negative 1. Now I'm going to take the LCM, so this is equal to 2 times of 1 negative t squared raised to the power 2 negative 1 positive t squared raised to the power 2 divided by the denominator, which is 1 positive t squared raised to the power 2. Now I'm going to expand the numerator. So expanding the numerator, this is going to be 2 of 1 negative 2 times t squared positive t to the power 4 followed by 1 positive 2 times t squared positive t power 4 divided by the denominator 1 positive t squared raised to the power 2. Now this is equal to, now 2 times 1 will give me 2 negative 4 t raised to the power 2 positive 2 times t raised to the power 4 negative, this is going to give me negative 1 negative 2 times t squared and negative t power 4 divided by 1 positive t squared raised to the power 2. So this is what I got. Now I'm going to place, add 2 with negative 1, that's going to be 1. Add negative 4t squared with negative 2t squared, that's going to be 6t squared, followed by t power 2 times t power 4 with negative t power 4, that's going to give me positive t power 4 divided by 1 positive t raised to the power 2. This is raised to the power of 2. Now what is this? This is nothing but cos 2x. Now this would mean my secant 2x is nothing but 1 over cos 2x, which is nothing but, I need to flip this. So this would give me my secant squared, secant 2x. So this is nothing but 1 positive t squared raised to the power 2 divided by 1 negative 6 times t squared positive t to the power 4. So I've got secant 2x and I've already got secant x. So now comes the final substitution and simplification. So hence the final question, the problem is integral dx divided by secant x positive secant 2x is equal to integral. Now my dx, we have already obtained the value of dx, so that is going to be this. So let me just place that on the corner. So 2 times dt divided by 1 positive t squared. Now this is 1 over, now my secant x is going to be 1 positive t squared divided by 1 negative t squared. So let me write that down. 1 positive t squared divided by 1 negative t squared followed by a positive sign, and my secant 2x, this is secant 2x is going to be this term. So that's going to be 1 positive t squared raised to the power 2 divided by 1 negative 6 times t squared positive t power 4. So this is what we've got. So now what I'm going to do, I'm just going to simplify this term first. So let me just consider the denominator, which is 1 positive t squared divided by 1 negative t squared positive 1 positive t squared raised to the power 2 divided by 1 negative 6 times t squared positive t power 4. Now I want to take the LCM. The LCM is going to be 1 negative t squared times 1 negative 6 times t squared positive t power 4. So these two terms gets neutralized, giving me 1 positive t squared times 1 negative 6 times t squared positive t to the power 4 positive. So these two terms gets neutralized, giving me 1 negative t squared multiplied with 1 positive t squared raised to the power of 2. So this is what I've got from the denominator. Now what I wish to do is I would like to take 1 positive t squared out. So this is equal to, I'm going to take 1 positive t squared out. When I do that, I would get 1 negative 6 times t squared positive t power 4 followed by a positive, and this is going to be 1 positive t squared multiplied with 1 negative t squared. 1 negative t squared. So this is what I've got, divided by the quantity over here is 1 negative t squared times 1 negative 6 times t squared positive t power 4. So this is what I've got. So now what I can do is I need to spread this out, because we need to do some simplification. So we need to just simplify and find what exactly we are getting over here. So this is equal to 1 positive t squared times, this is 1 negative 6 times t squared positive t to the power 4. Now this is a plus b times a minus b. So that would give me 1 negative t to the power 4 divided by the denominator 1 negative t squared times 1 negative 6 times t squared positive t to the power 4. This is what I've got. Now clearly I can cancel t to the power 4, negative t to the power 4, and that would give me 1 positive t squared times 1 added with 1 will give me 2, and negative, and I've got a 6t squared divided by 1 negative t squared multiplied with 1 negative 6 times t squared positive t to the power 4. Now what I can do, I can take a 2 out. If I take a 2 out, this is going to be 2 of 1 negative 3 times t squared times 1 positive t squared divided by 1 negative t squared times 1 negative 6 times t squared positive t to the power 4. So all of these things is emanating from the denominator. What have we got? So now what we need to do, we need to take this entire thing and substitute it here. So I'm going to rewrite it. So therefore integral, I've got 1 over this entire quantity. I'm going to substitute this entire quantity here. So 2 times of 1 negative 3 times t squared times 1 positive t squared divided by 1 negative t squared times 1 negative 6 times t squared positive t to the power 4. Of course I've got the quantity 2 times dt divided by 1 positive t squared. I've got this quantity. Now what I need to do is I need to flip this. So when I flip this, this is going to be equal to, this entire thing will go to the numerator. So this is integral, let me write that down, 1 negative t squared times 1 negative 6 times t squared positive t to the power 4 divided by, I got this quantity, it's going to be 1 negative 3 times t squared times 1 positive t squared. So this is one quantity, and I've got this 1 positive t squared, so that can be clubbed with this, so that's going to be a 2 there, and I've got a dt there, and let's see how the simplification goes on. Now the only way to solve this, or I would say the most preferred way to solve this, is by partial fractions. So let me write that down. Of course the 2 and the 2, they get cancelled, so no need to place it here. So using partial fractions, I'm going to rewrite this. So let's do that. So this is going to be 1 negative t squared multiplied with 1 negative 6 times t squared positive t power 4 divided by the denominator. I'm going to start by writing 1 positive t squared raised to the power 2 times 1 negative 3 times t squared. So I'm going to rewrite this in form of partial fractions, which is nothing but a over 1 positive t squared followed by b over 1 positive t squared raised to the power 2 followed by my c over 1 negative 3t squared and followed by the constant d. So I hope you all know this way of fractionalizing the quantity for the facility of integration. So now what we need to do is we need to cross multiply. So if I were to cross multiply, I would get 1 negative t squared times 1 negative 6 times t squared positive t to the power 4 to be equal to 1 positive t squared, 1 positive t squared will get cancelled. That would leave me with 1 positive t squared times 1 negative 3 times t squared followed by b times, so 1 positive t squared raised to the power 2 and the term over here gets cancelled, giving me 1 negative 3 times t squared followed by c times 1 negative 3t squared gets cancelled, giving me 1 positive t squared raised to the power 2 followed by the term d, which will involve all other terms. So 1 positive t squared raised to the power 2 times 1 negative 3t squared. Now what we need to do is we need to choose the values for t squared. Now I'm going to take the value first for, say, let t squared be equal to 0. Now if t squared is equal to 0, what happens? Clearly, if I were to substitute t squared is equal to 0, I need to extract the values for a and b. So let me just take a new page. So this is what we got on the left side. So I'm going to be substituting t squared is equal to 0. So that would mean I would get a of 1 positive 0 multiplied with 1 negative 3 of 0 plus b of I'm actually using the terms here. So b of 1 negative 3 of 0 plus c of 1 positive 0 raised to the power 2 positive d of 1 positive 0 raised to the power 2 of 1 negative 3 of 0. So substituting t squared is equal to 0. So this is nothing but t squared is equal to 0. On the left hand side, this is going to give me 1 negative 0 times 1 negative 6 times of 0 positive 0, and this will get cancelled, this will get cancelled, giving me 1 is equal to, now obtaining the value, this is going to give me a, and then this is going to give me the value b, a plus b plus, this is going to give me the value c, and 0 0, this is going to give me value d. So this is one system we have got. Now the next thing is I need to substitute. I'm going to take the value of t squared is negative 1. So let t squared be equal to negative 1. Now if that be the case, if I were to take t squared is equal to negative 1, so what happens if I were to substitute negative 1? Let me use the system. So this is going to be a of t squared is negative 1, so 1 negative 1, so the a term will get cancelled, followed by, in fact, all this entire term of a would vanish because of the fact that t squared is negative 1. So this is the system that we are using. So this is going to get cancelled, and in case of b, I've got a b of 1 negative 3, t squared is negative 1, I'm substituting the value, followed by c of t squared is negative 1, so c is going to get cancelled, c will vanish, and followed by d, t squared is negative 1, and my d will also vanish, so subsequently On the left hand side, I need to substitute the left hand side, so it's going to be 1 negative. My t squared value is negative 1, so this is going to be negative 1. I'm just going to substitute t squared as negative 1, followed by 1 negative 6 of negative 1, followed by t squared is negative 1, so this is actually t to the power 4. So let me show you that. So this is t squared times t squared is t power 4, so that will give me positive 1 for this particular quantity. So there's going to be positive 1 there, and this is equal to, let me write that down, 1 negative of negative 1, that's going to be 1 plus 1, that's going to be 2 there, followed by 1 negative negative positive 6 positive 1, so this is going to be 6 positive 1 7 and 8 times 2 is 16, so I've got a 16 here, and this is going to give me negative negative positive 3 added with 1 would give me 4, so this is going to be 4 times b. So from here, just for the sake of consistency I'm writing, so therefore b would be equal to 16 over 4, which is equal to 4. So the value of b is 4 here. So that is the first value we have got. So now what we need to do, we have already substituted t squared is equal to 0 and t squared is equal to negative 1. So now we need to take t squared is equal to 1 over 3 and substitute it in this equation which we have got. So I'm going to show you that. So on the left I've got 1 negative t squared, so this is going to be 1 over 3, followed by 1 negative 6 of 1 over 3, followed by 1 over 3 the whole squared, because it's t power 4, and that is equal to, now t squared is equal to 1 over 3, so it means my a term would get cancelled, my b term would get cancelled, and my d term would get cancelled, leaving me alone with the c term. So I need to just place that. So c of 1, my t squared is 1 over 3 raised to the power 2. So this is going to be equal to c of, taking the LCM as 3, this would give us 3 positive 1 over 3 raised to the power of 2, and on the left side this is going to give me 3 minus 1 over 3, and 3 divides, in fact I don't have to do it like this, but it's still okay. So 3 divides 6 2 times, so it's going to be 1 negative 2 positive 1 over 3 squared is 9. So 3 negative 1, this is going to be 2 over 3 on the left side, followed by 1 negative 2 is going to give me negative 1, followed by positive 1 over 9. On this end it's going to be 3 of 3 positive 1 will give me 4, so that's going to be 4 squared over 3 squared is going to be 9. So this is what we have got here. Now let me just simplify the other term. So this is going to be 2 over 3, I take the LCM as 9, so it's going to be negative 9 positive 1 is equal to 16 times c over 9. So this is going to be 2 over 3 of negative 9 positive 1 is negative 8 over 9, and you got 16c over 9. Now what we can do is the 9 and the 9 can be cancelled. My 2, okay, let me just push the 16 down, so let me use this space. So c is equal to 1 over 16 times 2 over 3 of negative 8. This is what we've got. So 2 divides 16 8 times, and 8 and 8 gets cancelled, giving me negative 1 over 3. So we got therefore c to be equal to negative 1 over 3. So that's a nice value we have got. Now having obtained this, we need to make one more substitution. So that substitution is for obtaining the value of b. So we have to take this substitution. So t squared is equal to 1. So after this substitution, t squared is equal to 1 over 3, we have to make this substitution. So let us substitute t squared is equal to 1 over here. Now let me show you this. Now if I were to substitute t squared is equal to 1, my left hand side will vanish, so I'm going to get 0. So t squared is equal to 1, my a will stand. Okay, so this is going to be a of 1 positive 1 times 1 negative 3 positive b of 1 negative 3, t squared is equal to 1, positive c of t squared is equal to 1. So 1 positive 1 raised to the power 2, t squared is equal to 1. My d will also stand, d of 1 positive 1 raised to the power 2 positive, it's multiplication not positive, 1 negative 3 squared is equal to 1, and that is it. So we will have to evaluate this. So let me do the evaluation here. So left hand side is 0, 0 is equal to my a of 2 times, this is 1 negative 3 is going to give me minus 2, followed by b of 1 negative 3 will give me negative 2, followed by c of 1 positive 1 is 2 raised to the power 2, followed by d of 1 positive 1 2, that's going to be 2 squared, that's going to be 4 right away there, and then 1 t squared is equal to 1, so it's going to be 1 negative 3, that's going to be negative 2. So all of these things we have to evaluate. So this is equal to 0 is equal to, this is negative 4 times a, negative 2 times b, followed by 4 times c, and negative 8 times d. This is what we've got. Now let us substitute the values that we've got. We've already got the value for b is 4, the value for c is negative 1 over 3. These are the two values we've got. Now we have got the value for, or we need to get okay, we got one more system we can use, so followed by negative 8 times d. So let me write that down. So this is 0 is equal to negative 4 times a, negative 2 times 2 times 4 is going to give me 8. So let me do the simplification here. So negative 8 and negative this is actually 4 times c, so this should be 4 here. So c is negative 1 over 3, so I need to add this with negative 4 over 3. So this is going to be 8 times 3 is 24, negative 4 over 3, this is negative 28 over 3. So followed by negative 28 over 3, and I've got negative 8d over here. So that is the simplification. So now we need to further down simplify this. Now let me rewrite this. This is going to be negative 4a, negative 8d, and I move this on the other end. This is going to be 28 over 3. Now let us take this as number 2. Now I already have equation with number 1. If you would have watched this, we have already have this. We got a positive, b positive, c positive, d is equal to 1. We have already added this. And now we got negative 4 times a, negative 8 times d is equal to 28 over 3. So let us simplify this. Now we already know the value of b. The value of b is 4. We already got a value for c. The value for c is negative 1 over 3. So negative 1 over 3, and we don't know the value of a, and d is equal to 1. So from here, this is 12 negative 1 over 3, positive a positive d is equal to 1. This is 11 over 3, positive a positive d is equal to 1. I move this to the other side. This is a positive d is equal to 1 negative 11 over 3. This is 3 negative 11 over 3. So this is going to give me 8 with a negative sign over 3. So this is a positive d is equal to negative 8 over 3. I'm going to use this. So this is going to be negative 4 times a negative 8d is equal to 28 over 3. Now if I want to remove a, all I need to do is, let me name it as equation number 3 and equation number 4. So if I multiply 3 by 4, that's enough. Let's check that out. So it's going to be 4 times a plus 4 times d is equal to negative 32 over 3, followed by negative 4a negative 8d is 28 over 3. Now these two gets cancelled, and I add this, I get negative 4d, and I need to add negative 32 over 3 positive 28 over 3. So this is going to be 3 there, negative 32 positive 28, so that's going to give me negative 4 over 3. And I substitute here negative 4 over 3, my negative 4 gets cancelled. This means my d is 1 over 3. Now if my d is 1 over 3, I can substitute it here, right? So put my d is 1 over 3 in 3. So let's see what happens. So this is going to be a positive 1 over 3 is negative 8 over 3. I move this to the other side. I get a is negative 8 over 3 negative 1 over 3. This gives me negative 9 over 3, which is equal to negative 3. So my a is negative 3. I've got the values of a, b and c and d, and now all it remains is to substitute it in the partial fractions that we have extracted and then integrate. Substituting the values of a, b, c, d, we get this, and all we need to do is to integrate. So I'm going to rewrite this as negative 3 times integral dt over 1 positive t squared, followed by positive 4 times integral dt over 1 positive t squared raised to the power 2, negative 1 over 3 times integral dt over 1 negative 3 times t squared, followed by integral dt with constant 1 over 3 on the outside. Now this is equal to, clearly this is tan inverse of t, and can place that positive. Let us not bother about this integration. I'm not going to do anything now. I'm going to retain it as it is. So dt over 1 positive t squared raised to the power 2. Now this is actually integral dx divided by a squared minus x squared. So there is a equivalent logarithmic expansion for this. And using that, this is going to be, this is an integral formula. So this is going to be 1 over 3 times with, because in this case we take x is equal to root of 3 times t and raised to the power of 2. So that would mean we can apply this formula. So if I were to apply this formula, this would become 1 over 2 times root of 3 times ln of modulus of 1 positive root of 3 times t divided by 1 negative root of 3 times t. This is what we would get. This is a straightforward substitution, and this is followed by 1 over 3 integral of dt. That's going to give me t. So it's going to be 1 over 3 times of t plus, of course, arbitrary constant. I don't want to retain place it now, but just for sake of consistency, let it be there. But we have a few challenges. The challenge here now is I have to make the substitution for t. Now before I could make the substitution for t, I want to resolve this. So what I'm going to do is I'm going to consider integral dt divided by 1 positive t squared raised to the power 2. Now you know that we actually started by taking t is equal to tan of x over 2. This is what our t is. Now if I were to substitute that, my 1 over t squared raised to the power of 2 is equal to this is going to be 1 positive tan squared x over 2 raised to the power 2. Now this is nothing but secant squared x over 2 raised to the power of 2. This is nothing but secant to the power of 4 x over 2. Now dt, now if t is equal to this, my dt is going to be secant squared x over 2 times 1 over 2 times dx. So that's the differential part we will have to handle. So now what we need to do is we will have to place in the substitution there. So let's do that. So if I were to substitute, this is going to be equal to integral, in place of dt, this is going to be secant squared x over 2. There is a 1 over 2. I want to place that 1 over 2 over there. And then I got a dx divided by 1 positive t squared raised to the power 2, and that is going to be secant raised to the power 4 x over 2. So this is what we have got. So now what we need to do is we will have to cancel the terms, and that would give us 1 over 2 times integral dx. Of course all these things are substitution. Dx divided by secant squared x over 2. Now secant squared x over 2 is actually cos squared x over 2, right? So I can rewrite this to be equal to 1 over 2 times integral, this is going to be cos squared x over 2 times dx. Now there is a trigonometric formula which is written as follows. Now cos squared x is equal to 1 positive cos 2x divided by 2. This is for cos squared x. Now if I were to take x is equal to x over 2, then I would have cos squared x over 2 is equal to 1 positive cos x over 2. So this is what I would have. Now this is equal to 1 over 2 times integral 1 positive cos x divided by 2, and that has to be multiplied by dx. So this is equal to 1 over 4 times integral 1 positive cos x times dx, which can be rewritten as 1 over 4 times integral dx positive integral cos x times dx. This is equal to 1 over 4 times integral dx is x, integral of cos x, that will give me a sin x term there. So it's going to be 1 positive sin x. Of course I've got arbitrary constant c, but I will use it at the end. Now all of this has led me to this. Okay, so in place of this I will have to substitute this. So in fact, therefore, my integration term which we started, we were able to do this, we were able to consider this integral quantity, and we have arrived at this particular point. So now this is equal to, let me write that down, negative 3 times tan inverse of t is here, right? So this is what is the original, this is where we stopped. Now we know that we have taken t is to be as tan of x over, we have taken t to be as tan of x over 2. So I need to substitute that. So that's going to be tan of x over 2 positive 4 times, I need to substitute this value for that term. So it's going to be 1 over 4 times x positive sin x, and followed by negative 1 over, this is going to give me 3 times 2 is 6 times root 3, so that's going to be 6 of root 3 times ln of 1 positive root 3 times t. My t is tan of x over 2, so just substitute that tan of x over 2 divided by 1 minus root of 3 times tan of x over 2, the modulus sign is there, plus 1 over 3 times my t is tan of x over 2. So this is what I've got, plus of course arbitrary constant c. Now you can do a few simplifications. What you can do from here, this is going to be negative 3x over 2, that is fine, and my 4 and 4 will get cancelled, giving me x positive sine x there, and then followed by, is there anything, this is x over 2. So let me write this term 6 times root of 3 ln of 1 positive root of 3 times tan of x over 2 divided by 1 negative root of 3 tan of x over 2 positive 1 over 3 times tan x over 2 positive constant c. So this is the final outcome, students. Of course we can simplify this. This is there. This can lead us to 2x negative x over 2. So this would be negative x over 2. So I think we can stop. This is the right place to stop our solution. Thank you, students.